Welcome second year B.Sc student. Paper is calculus of several variable. Unit number 4, double and triple integration. This is video of change of variable from Cartesian to polar in double integration. Dear friend, first subscribe my YouTube channel PV Patil to evaluation of double integration by change of variable. Now in first, to evaluate double integration by change Cartesian coordinate to polar coordinate. To understand this topic, first you got what is Cartesian form and what is polar form. First topic is Cartesian coordinate. In standard form, the Cartesian coordinate are x, y. For that, consider two-dimensional plane, x-axis and y-axis origin. This line x-axis, this line y-axis, and this point is origin. Now in standard form, the Cartesian coordinate of point P are x, y. Draw PM perpendicular on the x-axis and therefore OM distance is nothing but x and PM distance is y. We all familiar with this. Now what is polar coordinate? Polar coordinate are nothing but r, theta. So for that, again consider two-dimensional plane. This point is origin and this line called as initial line. Now the polar coordinate of point are r, theta. Now what is r and what is theta? R is the distance of this point P from the origin. Means OP distance is r. OP distance is r, and theta is an angle made by this line OP with the initial line, means this angle is theta. Therefore polar coordinate of point P are r, theta. Now what is relation between Cartesian coordinate and polar coordinate? Let Cartesian coordinate of point P are x, y and corresponding polar coordinate of point P are r, theta. So for that, consider two-dimensional plane. This line has x-axis, this line is y-axis, this point is origin. Now P point whose Cartesian coordinate x, y. So draw PM perpendicular on the x-axis. So OM distance is nothing but x and PM distance is y. Now the corresponding polar coordinate of point P are r, theta. So join OP. So OP distance is r. OP distance is r and line OP make an angle with initial line is theta. Therefore, from the right angle triangle OPM, cos theta equal to, we know formula cos theta is adjacent side upon hypotenuse. So cos theta equal to x upon r and sin theta is opposite side upon hypotenuse, means sin theta equal to y upon r. And therefore we get x equal to multiply by r, x equal to r cos theta and y is equal to r sin theta. X is r cos theta and y is r sin theta. This is relation between Cartesian coordinate and polar coordinate. Now the method to convert double integration in Cartesian coordinate to polar coordinate. Now we know in one variable. Now we know if the integration is one variable in this way, to put this equation as x square equal to t, means first step put x square equal to t, then find the value of dx and then change the limit as x is 0, write down value of t. One variable to other variable, find the value of dx and change the limit. Same procedure in Cartesian coordinate to polar coordinate. There are three steps. First step, write down x and y in terms of r and theta. First write x and y in terms of r and theta. By using the formulas, put x equal to r cos theta, y equal to r sin theta. Second step, find the value of dx dy in terms of dr d theta. Step number 2, write dx dy in terms of dr d theta. Use the formula dx dy equal to Jacobian of x, y with respect to r, theta dr d theta. Now simplify the Jacobian. Therefore dx dy is equal to Jacobian of x, y with respect to r, theta is a determinant whose first row dabba x by dabba r, dabba y by dabba r, second row dabba x by dabba theta, dabba y by dabba theta, dr d theta is equal to determine. Now first write down dabba x by dabba r. X is r cos theta, dabba x by dabba r is only cos theta, dabba y by dabba r, partial derivative of y with respect to r is sin theta, dabba x by dabba theta, partial derivative of x with respect to theta is minus r sin theta, and dabba y by dabba theta, partial derivative of y with respect to theta is r cos theta dr d theta. Now expand this determinant, first this product and then this product, equal to, now this product r cos into cos is cos square theta. Now minus of this minus become plus, this product is r sin square theta dr d theta. Now from this bracket r common, inside the bracket cos square plus sin square, this is 1, so remains only r dr d theta. Put the value of dx dy as r dr d theta, and step number 3, change the limit. By using the given integration limit, draw the diagram and find new limit of r and theta. Means there are 3 steps. First step, step number 1, put x is r cos theta, y is r sin theta. Step number 2, dx dy equal to r dr d theta. And step number 3, change the limit of xy to new limit of r and theta. Now by using this method, evaluate example. First example, change into polar coordinate and then evaluate double integration. First integration limit 0 to infinity, second integration limit 0 to infinity, e raised to minus of x square plus y square dy dx. Means given integration is in Cartesian form. First change into polar form and then evaluate this double integration. We know the method. Step number 1. First put the value of x and y in terms of r and theta. Therefore, so put x equal to r cos theta and y equal to r sin theta. Step number 2. Write down the value of dx dy in terms of dr d theta. Now we know the formula dx dy is r into dr d theta. And step number 3. By using the limit of given integration, find new limit of r and theta. In given integration, x varies from 0 to infinity and y varies from 0 to infinity. In given integration, x varies from 0 to infinity, y varies from 0 to infinity. Now the region is bounded by x is 0, x is infinity, y is 0, y is infinity. By using this equation, draw the diagram. So for that, consider two-dimensional plane. This point is origin, this line has x-axis, this line is y-axis. We know equation of y-axis is x equal to 0. Now draw the line x equal to infinity. The line x equal to infinity is parallel to y-axis. This line is x equal to infinity. Next line y equal to 0 is equation of x-axis, y equal to 0. Now y equal to infinity is a line parallel to x-axis at the distance of infinity from the x-axis. This line is y equal to infinity. Now this point of intersection is infinity comma infinity. Therefore the region bounded by x is 0, x is infinity, y is 0, y is infinity, means this region is required region. Now in this region, find the value of r and theta. Now this region is from this line to this line. So therefore this angle theta, first this line to this line angle is 0 and this line to y-axis angle is 90 degree. So theta varies from 0 to 90 degree. Theta varies from 0 to pi by 2. Now value of r is, the value of r is the distance from this point to origin. Origin to origin distance is 0, means r varies from 0 to, and maximum value of r, find the distance between this point and origin. This distance is infinity, so r varies from 0 to infinity. We get new limit, theta varies from 0 to pi by 2 and r varies from 0 to infinity. So convert given integration in polar form Therefore, given integration 0 to infinity e raised to minus x square plus y square dy dx is equal to. Now in polar form, integration theta varies from 0 to pi by 2. Next integration r varies from 0 to infinity e raised to minus r. Put the value of x is r cos theta, so x square become r square cos square theta plus put the value of y is r sin theta, so y square become r square sin square theta and value of dy dx is r dr d theta and therefore is equal to integration limit theta varies from 0 to pi by 2. Next integration r varies from 0 to infinity e raised to minus r. From this bracket r square common, so minus r square. Inside the bracket cos square plus sin square, this value is 1 into r dr d theta. Now for to evolution of this integration, here put the value of r square equal to t. Put the value of r square is t. Now differentiate this, derivative of r square is 2r dr is dt and therefore r dr is dt upon 2. Now also change the limit as r is 0. As r is 0, put the value of r is 0, we get t is 0. When r is infinity, t is also infinity. So limit same, therefore is equal to integration limit theta varies from 0 to pi by 2. Next integration limit t varies from 0 to infinity. Convert in terms of t. e raised to minus of r square is t, so minus t. r dr is dt upon 2 into d theta. Now write down 1/2 constant out of both integration. So 1/2 integration limit theta varies from 0 to pi by 2. Next integration limit t varies from 0 to infinity e raised to minus t dt into d theta. Now integrate this with respect to t. Integration of e raised to minus t is e raised to minus t divided by coefficient of t minus 1. So integration of e raised to minus t is minus e raised to minus t. T varies from 0 to infinity d theta. Now here first put upper limit infinity, then put lower limit t. So equal to 1/2 integration limit theta varies from 0 to pi by 2 inside the bracket minus of e raised to infinity minus of minus become plus e raised to 0 d theta. Now e raised to infinity is 0 and e raised to 0 is 1, so 0 plus 1. 1/2 integration limit theta varies from 0 to pi by 2 inside the bracket 0 plus 1 d theta equal to 1/2 integration only d theta and integration of d theta is theta 1/2 inside the bracket theta and theta varies from 0 to pi by 2. Now first put the value of theta is upper limit pi by 2 minus put the value of theta is lower limit 0. So 1/2 inside the bracket pi by 2 minus 0 and is equal to pi by 4. Example number 2. Change into polar coordinate and then evaluate integration limit 0 to 2, integration limit 0 to square root 2x minus x square, x upon square root x square plus y square dy dx. Means evaluate this integration by changing Cartesian coordinate to polar coordinate. So for that there are 3 steps. Step number 1, put the value of x and y in terms of r and theta. So put x equal to r cos theta and y equal to r sin theta. Step number 2, write down the value of dx dy in terms of dr d theta. Therefore dx dy equal to r into dr d theta. And step number 3, by using the limit of given integration, find new limit, means find the limit of r and theta. Now in given integration, x varies from 0 to 2 and y varies from 0 to square root of 2x minus x square. Therefore region bounded by x is 0, x is 2. Region bounded by x is 0, x is 2, y is 0 and y equal to square root 2x minus x square. Squaring both sides we get y square equal to 2x minus x square. Now write down all the term on left hand side. Therefore left hand side become x square plus y square minus 2x equal to 0 is equation of circle. This equation of circle is in general form. Find the center and radius of this circle. So for that, compare this equation with general form x square plus y square plus 2gx plus 2fy plus c equal to 0. So 2g equal to minus 2, therefore g equal to minus 1. 2f means coefficient of y is 0, 2f is 0, so f is 0. C means constant term is 0. Therefore center is minus g minus f. Center of this circle is minus g minus f, so plus 1, 0. And radius equal to square root of g square plus f square minus c equal to square root of g square is 1, f square 0, c is 0, so root 1 equal to 1. Center is 1, 0 and radius is 1. So draw the diagram by using given limits. So consider x and y axis and origin. This point is origin. This line is x axis whose equation is y equal to 0. This line is y axis whose equation is x equal to 0. X is 0, x is 2. We require two lines. Consider the region. X is 0. Now next line x is 2. This line is parallel to y axis and passing through point 2, 0. Here is point 2, 0, a point 2, 0. So line parallel to y axis and passing through point a 2, 0 is x equal to 2. Next line y is 0 means x axis. Then center of this circle is 1, 0. This point is in the center of O and A. This point is center of the circle and radius 1. So circle, draw the circle passing through point O and A. This is a circle. Now the region bounded by x is 0, this line, x is 2, this next line, then y is 0 and circle. So this portion half circle above the x axis is required region. Now in this region, theta from this point to this point means theta varies from 0 to pi by 2. In this region theta varies from 0 to pi by 2. Now find the value of r, limit of r. So for that consider equation of circle and put the value of x is r cos theta, y is r sin theta in equation of circle. Equation of circle is x square plus y square minus 2x equal to 0. Here put x is r cos theta and y is r sin theta and simplify this. We get r square cos square theta plus r square sin square theta minus 2r cos theta equal to 0. Now from the first two term r square common, inside the bracket cos square plus sin square is equal to 2r cos theta, and therefore r square minus 2r cos theta equal to 0. Here r common, into bracket r minus 2 cos theta equal to 0. So r equal to 0, r by using second factor r is equal to 2 cos theta, means the limit of r, that is r varies from 0 to 2 cos theta, r varies from 0 to 2 cos theta, and therefore given integration limit 0 to 2, integration limit 0 to square root 2x minus x square, x upon square root x square plus y square dy dx is equal to. Now write down this limit in terms of polar coordinate r and theta. So double integration, first integration limit theta varies from 0 to pi by 2, second integration limit r varies from 0 to 2 cos theta. Put the value of x is r cos theta upon square root of r square cos square theta plus r square sin square theta, and dy dx is r dr d theta, and therefore is equal to integration limit theta varies from 0 to pi by 2. Next integration limit r varies from 0 to 2 cos theta. Numerator is r cos theta upon, in square root r square common, inside the bracket cos square plus sin square into r dr d theta. Now we know cos square plus sin square is 1. So here remains only square root of r square. Square root r square means r only, and then this r and r cancel, so remains only integration limit theta varies from 0 to pi by 2. Next integration limit r varies from 0 to 2 cos theta r cos theta dr d theta. Now first integrate with respect to r. So in this integration cos theta is a constant. Integration limit theta varies from 0 to pi by 2, cos theta constant. Now integration of r dr is r square by 2. Integration of r is r square by 2. R varies from 0 to 2 cos theta d theta equal to 1/2 constant. First write down out of the integration. Integration limit theta varies from 0 to pi by 2. This is cos theta, and put the value of r is 2 cos theta. So 2 cos theta bracket square minus of put lower limit value of r is 0, so 0 into d theta. Therefore equal to 1/2. Integration limit theta varies from 0 to pi by 2. This is cos theta, and 2 cos theta bracket square is 4 cos square theta d theta. Now 4 out of the integration, so 4 upon 2 is 2 only. Integration limit theta varies from 0 to pi by 2. Cos into cos square is cos cube theta d theta. Now find the value of this integration by using reduction formula. We know reduction formula, integration limit 0 to pi by 2 cos raised to n theta d theta equal to n minus 1 upon n minus 3 upon n minus 2 up to 2 by 3 into 1 if n is odd. Here n equal to 3 is odd, so by using this formula equal to 2 into. Now value of this integration by reduction formula is 3 minus 1 2, so 2 by 3 into 1 and is equal to answer is 4 by 3. Example number 3, change into polar coordinate, then evaluate double integration xy into x square plus y square bracket raised to 3 by 2 dx dy over the first quadrant of this circle x square plus y square equal to 1. Means evaluate this double integration for conversion of Cartesian coordinate to polar coordinate and evaluate it. So there are 3 steps. Step number 1, first put the value of x and y in terms of r and theta. So put x equal to r cos theta and y is equal to r sin theta. Step number 2, write down dx dy in terms of dr d theta. Therefore dx dy equal to r into dr d theta. Now draw the diagram and find the limit of r and theta. So we know given curve is circle whose equation is x square plus y square equal to 1. Means this is a standard circle whose center 0 0 origin and radius is 1. So consider x and y axis. Origin, this is origin, this line is x axis, this line is y axis. Equation of x axis is y equal to 0, equation of y axis x equal to 0. Now consider point A.10 on the x axis, A.10. Then the circle whose center origin and radius 1. So draw the circle, center origin radius 1. This is a circle. Now the required region is in the first quadrant of this circle. Only part of first quadrant of this circle is required region. Now in this region find the limits of r and theta. In the first quadrant theta varies from 0 to pi by 2. Now find the value of r. So consider equation of circle x square plus y square equal to 1. Here put the value of x is r cos theta and y is r sin theta. So we get r cos theta bracket square plus r sin theta bracket square equal to 1. So we get r square cos square theta plus r square sin square theta is 1. R square common into bracket cos square plus sin square equal to 1. So r square equal to 1 and therefore r equal to plus r minus 1. But in the first quadrant value of r is only positive plus 1. Initial value of r is 0. Means r varies from 0 to 1. In the first quadrant r varies from 0 to 1 and theta varies from 0 to pi by 2. Therefore double integration xy into bracket x square plus y square bracket raised to 3 by 2 dx dy is equal to integration limit theta varies from 0 to pi by 2. Second integration limit r varies from 0 to 1. Now here put the value of x is r cos theta and y is r sin theta. So r cos theta into r sin theta inside the bracket x square plus y square means r cos theta bracket square plus r sin theta bracket square total bracket raised to 3 by 2 and value of dx dy is r dr d theta. Now simplify this. Integration limit theta varies from 0 to pi by 2, r varies from 0 to 1. This r into r become r square cos theta into sin theta. Inside the bracket r square cos square theta plus r square sin square theta bracket raised to 3 by 2 into r dr d theta is equal to we get integration limit theta varies from 0 to pi by 2. Next integration limit r varies from 0 to 1 r square into cos theta sin theta. Inside the bracket r square common into bracket cos square plus sin square is 1, so remains only r square raised to 3 by 2 into r dr d theta. Here 2 to cancel, remains only r cube is equal to integration limit theta varies from 0 to pi by 2. Next integration limit r varies from 0 to 1. This is r square cos theta sin theta into r cube into r dr d theta is equal to we get integration limit theta varies from 0 to pi by 2. Integration limit r varies from 0 to 1. R square into r cube is r raised to 5 into r is r raised to 6 into cos theta sin theta dr d theta. Now first integrate this term with respect to r. Integrate this term with respect to r. So integration limit theta varies from 0 to pi by 2. Cos theta sin theta is a constant. Integration of r raised to 6 is r raised to 7 upon 7. R varies from 0 to 1 d theta. Now here first put the value of r is 1 and then put the value of r is 0. So is equal to we get first write down 1 half and multiply by 2 is equal to 1 half integration limit theta varies from 0 to pi by 2 cos theta into sin theta. Inside the bracket put the value of r is 1, so 1 by 7 minus r put the value of r is 0, so 0 d theta. So this become 1 by 14. 1 by 14 integration limit theta varies from 0 to pi by 2. Now we know trigonometric formula 2 cos theta sin theta is sin of 2 theta. 2 sin theta cos theta is sin 2 theta d theta is equal to 1 upon 14. Now integration of sin is minus of cos of 2 theta divided by coefficient of theta is 2 and limit theta varies from 0 to pi by 2 is equal to take minus sign out of the bracket, so minus 1 upon 14 into 2 28 minus 1 by 28. Inside the bracket first put the value of theta is upper limit pi by 2, so cos pi minus of put lower limit cos 0, so equal to minus 1 by 28. Inside the bracket minus 1 minus 1, this is minus 2, so equal to minus 1 by 28 into minus 2 is 1 upon 14 is required answer. Dear friend, subscribe the channel and share to our friend. Thank you.